This one is problem 36. And we have r of x equal 8x squared plus 26x plus 15 over 2x squared minus x minus 15. So start off, same as before, find domain. So we look at where the denominator equals 0. I think that'll factor. Let's see, 2 times negative, we'll check to see if it factors. 2 times negative 15 is negative 30. Have to have a factoring pair, it has a difference of 1. Oh, 6 and 5. 6 and 5. 2x squared minus 6x plus 5x minus 15. Group. 2x times x minus 3, or x minus 3 plus 5 times x minus 3. So that's 2x plus 5 times x minus 3 is not equal 0, so that means x is not equal 3, or negative 5 halves. So domain is x such that x is not equal 3 or negative 5 halves. Intercepts. Well, I guess I need to know where the top is 0, so I gotta factor it as well. See, 8 times 15, 30, 60, 120. Need a factoring pair of 120. Has to add up to be 26. 10 and 12 are too close together. 8? Does 8 go into that? I think it does. 8 goes in. Let's see, divide by 4. Divide by 2. 8 and 15. That gets you 23. Still too close together. 7 doesn't go in. 6 goes in? Oh, 6 goes in. 6 and 20. That's the one. So 8x squared plus 6x plus 20x plus 15. Group. Pull out 2x. This is factoring by grouping, if you are not familiar. 4x plus 3. 5 times 4x plus 3. 4x plus 3. 2x plus 5. Got 4x plus 3 times 2x plus 5 over 2x plus 5 times x minus 3. Alright, so we reduce this one. We will have a 0 where 4x plus 3 equals 0, so x-intercept at negative 3/4. Y-intercept, if I plug in 0, I would get 3 over negative 3. So y equals negative 1. Moving right along. Vertical asymptotes. Well, note, we do not have one at negative 5 halves. Although it is not in the domain, it did reduce. So in that case, it's not a vertical asymptote. We only have a vertical asymptote at x equal 3, because that's the only 0 left of the denominator. In this case, the numerator and denominator polynomial have the same degree. Well, if you look at our list, if m equals n, it has a horizontal asymptote at y equals 8 over 2 or 4. You can also do it with the reduced version, 4 over 1. I don't want to put that there, I'm running out of room. R of x equal 4x plus 3 over x minus 3. And I think we're ready to start graphing this thing. So we have a vertical asymptote at x equal 3. So I'll draw a dotted line there. We have a horizontal asymptote at y equal 4. So I'll draw a dotted line there. We have a y-intercept at -1. We have an x-intercept at -3/4, so about right there. And lastly, I'm also going to look at a very specific point. I'm going to look at -5/2. We don't have a point there, but we're going to have an empty point there. So if I plug into this, r of -5/2, we will get 4 times -5/2. I could do this in the calculator, but -5/2 minus 3. So I'm going to multiply top and bottom by 2. That'll be 4 times -5 plus 6 over -5 minus 6. So that's -20 plus 6 is 14. -14 over -11. So that's 14/11ths. So at -5/2, that's -2.5. 1, 2.5. It's just slightly over 1. 1 and 3/11ths. That's about 1 and a little under a third. So that's where it would be. We put an empty circle there. That means it will go up. Our curve will go up to that point and come out the other end, but there will not be a point actually there, because it's not in our domain. Rest of this is just plotting. So let's grab our grapher and have it calculate some points for us. So if we plug in, I'm going to plug in this version. It's just simpler to plug in, less typing. Don't forget your parentheses. 4x plus 3 divided by x minus 3. Look at our table. That honestly gives us a good range to work with, regardless of our set. I'm going to start off to the left of the vertical asymptote. So we have 2, -11. So 2, -11 is down there. We have 1, -3.5. So honestly, you can already tell that part pretty well. Let's see about this side. If I look at -4, it's about 1.8. Let's go all the way out to -10. -10 is about 2.8. So it's approaching the horizontal asymptote just very slowly. And if we look on the other side of the vertical asymptote, you can see there, we might not be able to actually plot that point all the way up at 19, but you get the gist. 5 is 11.5. It's coming down towards 4 as well. So 5 is 11.5. So right there. 6 is 9. 7, let's see, 8 is 7. So I believe it would be right here. And 10 is 6.14. So it's also slowly tending down towards it. Honestly, based on what I now know, it would probably look a little bit better if I made my y's be, say, 2's instead of 1's, but oh well. It doesn't look that bad. The important part is don't forget about the empty point here. And your asymptotes. Our last problem of the video is problem 15. Here we have h of x equal x cubed minus 1 over x squared minus 9. So domain. Well, this would be pretty easy. I can factor the bottom pretty easily. That's x plus 3, x minus 3. So domain is just all real numbers except 3 and negative 3. Probably should have just done a plus or minus. If you try and find all the intercepts, we already factored the denominator, x plus 3, x minus 3. The top is a difference of cubes, so a cubed minus b cubed is a minus b times a squared plus ab plus b squared. If you don't remember the formula, that's what it is. So x minus 1 x squared plus x plus 1. Doesn't look like anything's going to reduce. This only gives imaginary numbers, so the only 0 is going to be at 1. So x-intercept at x equal 1. Y-intercept. If I plug in 0, I would get negative 1 over negative 9, so y equal 1/9. Vertical asymptotes. Pretty simple. Nothing reduces, so x equal 3 and negative 3. Now, in this case, the top degree is 1 more than the bottom degree, so we have a slant or oblique asymptote. We got to do some division. So I divide x cubed. I'll go ahead and leave space for my missing powers, but plus 0x squared plus 0x minus 1 divided by x squared minus 9. Can't do synthetic division because my denominator is not just x minus 9. It can't have a power if you're doing synthetic division. Also can't have a coefficient unless you're going to do some other work with it. Let's see, x cubed divided by x squared is x, so x times gets me x cubed. See, that'll be minus 9x, so it'll be under this one. Do your subtraction, so minus and plus. This becomes 0. This becomes negative 9x minus 1. No, plus 9x, my bad. Plus 9x, because I subtracted a negative. Yeah. So then, x squared won't go into that, so we're done. Y equal x, our quotient, is our slant asymptote. Alright, should be ready to graph. So, plot our asymptotes. Plot our vertical asymptotes. Because the slanted asymptote is and a slanted line. I'm not as anxious to plot it before I look at some of the points, but honestly, y equal x is so simple. It's just the diagonal. So I think I'll go ahead and plot it. Just have to diagonally bisect each one of these little cute squares. Now we need to talk about our intercepts. There's no empty points, so just intercepts. X-intercept here at 1. Y-intercept at 1/9, so just slightly above the asymptote. And grab our calculator. Plot in parentheses x to the third minus 1 divided by, in parentheses, x squared minus 9. Close that. Look at the table. Let's see. Let's do the middle first. It's not very symmetrical. -2, 1.8, -1.25, 0, 0.111. Already put that one in. That's the 1/9 one. So I'll just plot in these other points here. 2, -1.4. So about right there. -1.25. So that's quarter. -2, 1.8. So that's about right here. Looks like it's going to go like this. And then on the other side of the -3, we have these values. It's staying pretty low. Look at some of those. The main thing I want to do is look at some things pretty close to the asymptotes. So if we look at -4, it's already down at -9. So it's really down in this area. Let's look at a value really close to it, though. Let's say -3.5. I gotta wait. That at least validates what we're doing, though. -3.5. So yeah, that's 13.5. So that's down pretty low. Okay. So -3.5. Here's 10. 13.5 is down here. Plot some of the other points in that table. -4 is up at -9.2, so that's about right here. -5 is -7.8, 7.9. So there's 9, 8, 7.9. -6 goes back below 8, just barely though. Basically on top of 8. -7 goes down to -8.6, so it's starting to go down again. -10, might as well jump out there, is -11. We're going like this. Yep. And then down here, hugging that asymptote. So hugging the vertical asymptote, hugging the slanted asymptote. I assume the other bit will be in here. We'll see. It looks like it. 4.9. If I do the trace of 3.5, yeah, we're up at 13. 12.9, basically. So if you do that, 3.5, 12.9, yeah, all the way up there. And you plot those other points. Plot 4. Sorry I can't keep the calculator on screen while I'm doing this. It's just the nature of doing it. 5, 7.75. So that's 9. 8, 7.75 is about right there. 6, 7.9, so it's going back up. 7, 8.55, so it's right at 8.5. 10 is right about 11. So we got this. Comes around. Approaches the asymptote. So there we go. That's all three cases. Horizontal asymptote, both horizontal asymptotes and a slanted asymptote. That'll be it for this video. Finish this off on rational functions. When we come back, we will talk about polynomial and rational inequalities. It'll basically be building on what we did with quadratic inequalities at the end of the last chapter. It'll be very similar to that. With more complicated graphs, there's more complicated tests for the inequalities, but it's still very similar. Have a great day. See you then.